Okay, so how are we all doing? I guess we're all fine. I'm happy to say this will be final official class, and it's not going to be that kind of lengthy. We'll just take out our time to explain what containerization is, and then we'll explain what Docker is and how we can use Docker to containerize our Node.js app. And I think I prepared some notes for you. So we'll go briefly through these notes and then see what you've got here. Okay. Let's check out the docs and then the Docker MD. Okay. Let's zoom in a little bit. So in one of our previous classes, I explained what containers are and what virtual machines are. So if you've forgotten or you want to still know what a container is, you can basically rewatch that class video, or you can come here and check is it load balancing and okay, not that, or virtual box. We talked about hypervisors, and in here we differentiated between virtual machines and containers. Yeah, difference between virtual machines and containers, the architecture, resource utilization, isolation, portability, and all of that. Okay, so let's just move straight to the point. What is Docker? Docker is a technology that allows you to package your application and its dependencies into a single lightweight unit called a container. And the second question pops up. Why use containers? Containers are likely to self-contained packages for your applications. They include everything your app needs to run, such as the code, libraries, and settings. This means you can run your application consistently across different environments, like your local computer, a testing server, or a production server, without worrying about the behavior of your application. It can run across different platforms, different operating systems, like the Linux operating system, um, the Ubuntu, the Windows, or the Mac operating system, without any inconsistencies. In Docker, we have key terms, and the major key terms here, we have the image, container, and a Docker file. So an image is a blueprint of a container. It contains all the necessary files, libraries, and configurations to run your application. Then a container, a running instance of an image. It's like an isolated environment for your application to run in. Then a Docker file. A Docker file is a text file that describes how to build a Docker image. It specifies what needs to be included in the image and all of those other things. Okay, so how Docker works? Um, how does Docker work? Docker uses a client-server architecture, and the Docker client communicates with the Docker server, which does the heavy lifting for us. Okay, And getting started with Docker. To get started with Docker, you typically follow these few steps. You install Docker, and you need to install Docker on your computer. You can download it from the Docker website. Secondly, you create a Docker file in the root of your project, and you run a container and all of that. So what are the benefits of Docker? So the portability, containers can run consistently across different environments, which helps with with development and deployment. And then the second benefit of Docker is an isolation. Containers are isolated from each other from the host system, ensuring that one app doesn't interfere with another. The resource efficiency. Containers are lightweight and share the host operating system's kernel, making them efficient in terms of resource usage. The scaling. Docker makes it easy to scale your application by running multiple containers of the same image. Use cases. Docker is widely used for web application deployment, microservices, continuous integration, and continuous deployment pipelines. The Docker ecosystem. We have the Docker Hub, a registry for Docker images where you can find and share pre-built images. The Docker Compose, a tool for defining and running multiple container applications. And then the last but not least, Kubernetes, also known as K8. K8 is a container orchestration platform that can manage Docker containers at scale. And Docker in combination with K8, you can use Docker in combination with K to load balance your application. You can use it as load balancers to load balance your application actually. Well, I'm not going to be talking about the K8. The Docker MD5 is here. You can actually come back to read about K8 and try to make your own findings. So how to build a Docker image for our KCTM app. So basically, what you can do to build an app for our KCTM app is visit this URL and select your operating system in the drop-down menu. You can also check the manual on how to install it on your command line. Okay, so we're going to be, let's open this in a new tab. This is the Docker official website, and here you can see the #1 containerization software for developers and teams. So if you click on this drop down menu, you see download for Mac Intel chip, download for Windows, download for Linux, and the first option is download for Mac Apple chip. Okay, so I am using a Mac, so I downloaded for the Intel chip, not the Apple chip. So you can also visit the developer option here, the docs, getting started, and any other thing you wish to check out. So you can click here, select the docs, and under the docs we have get started, download and install, language specific guides. We have the manuals. You can also click on the manuals and then check on Docker engine, Docker CLI client, Docker Scout, and all of that. But for now, what we're going to be doing is come back to our docs and then open up let's open up VS Code so we can okay, so I guess I already have this opened. Why is it taking time to load actually? Okay, so let's open up the terminal and then kill this one. In fact, kill this one as well. And then reopen it. Okay, so now This is the root of our project. We have the docs and we have every other thing here. So the first thing we're going to be doing is we have the instructions here. So you can create a new minimal app. If you want to learn Docker, you can create a new minimal app or use your KCTM app or your blog API app. So after that, you create a Docker file in the root of your project directory and paste the following content. After pasting it, we're going to be explaining it line by line. But first of all, what I will do is I'll come to the root of my project here, then create a new file, call it a Docker file. So inside of this Docker file, okay, let's see, create, okay, create a minimal Docker file. So it's like this. Okay, let's just come here, copy this, and then paste it here like this. Let me zoom in a little bit. Zoom in. Okay. So let's try to explain this line by line. So what's going on here? And let's hop back to our document. So let's break this down each line. Let's break down each line of the Docker file for application. So in our Docker file, we're having from node 14. Well, here I actually changed it from 14 to latest so we can actually know what's going on. So this line specifies the base image as an official node latest image. So it's a foundation for your NodeJs application. So I can actually come here and change it to slim. Slim. Okay, so for us to understand this better, let's just I think we should visit Docker Hub. Okay, Docker Hub. Let me see. Let me just sign in. Okay. Okay, it's loading. So I'm logged in as coding Simba. And what should I explore here? Okay, I don't have any repositories, but then let me explore. So we'll be viewing the official Docker images. Now let's search for node. Let's search for node here. And when we locate node, we can see we have let's click on the tags here and check out the tags available. As you can see, we have the latest, we have the slim, we have the LTS slim, is it the LTS ion, and the rest of it. You can actually pull this from the Docker Hub. You can see Docker pull node latest, Docker pull node slim, Docker pull node LTS ion, all of that. So what we're going to be doing is we're going to be using this slim tag. We're not using the latest. Actually, the latest is 382.14 MB, 0.14 MB, and the slim is in size 778.16 MB. So we're going to be using the slim, the Docker slim tag here, because it's lesser in size and we are not taking our app to production. It's just for testing purposes. Okay, so what we're going to be doing now is we'll specify the image tag here, which is node. The image is node and the tag is slim. Okay, so now the second item in this file is the work directory, which is /app. And basically why it's /app is because this sets the working directory within the container to /app. You replace your application code and run commands in this directory. And the third item is copy package.json. So this line copies your package.json and package.log.json files from your local directory to the containers working directory, which is the app directory. This step is crucial for installing your application's dependencies. After it copies this, then it will run npm install. It runs npm install your applications to install your application dependencies listed in package.json within the container. So after it specify your work directory, it will copy the package log and package.json to the work directory and try to install your dependencies. Okay, so actually you can come back here and do something like try to remove this asterisk and sign here, because after you copy your package.json and you install everything, the package log.json file will also be created. But in this case, what we want to do is want to just copy both files, so we don't have to recreate the package log.json, but actually remove this. It's still the same thing. Then we have this copy line here, which says this copies the rest of your application code, includes your source/index.js file and any other files or directories into the containers working directory, which is the app directory here, and then expose 3000. This line exposes for 3000 in the container, which is where your Node.js application may be listening. It doesn't automatically expose the port to the host. You'd have to do that when running the container. So when you run this, you install your dependencies, then you copy your application code to the working directory, then you expose this port so that you can be able to access your application. Quite alright. So after that, you are now ready to sorry, you're now ready to start your application. And if you can check in the package.json here, we have the start command. The starts in our script here, we have the start command, which is a node src/index.js, and for us to start it, we'll run npm run start. Let's make sure it's npm run start or npm start, like so. Npm start, or the same, npm run start, npm start. Okay, our app is now running, so actually it's working. So let's come back to a file. So this command that this is the command that executes when it's executed when you run the container. In this case, it starts your Node.js application using the start script in the package.json file. You can customize this command to match your application's entry point. That's quite alright. So after creating our Docker file, you can build a Docker image and run your Node.js application in a container by using the following command. So in this case, you have docker build, the tag, the dash t here is dash, you can say dash tag, but I like using shorter commands and shorter options. I don't like including the whole body. I'll just use the short form of it. So docker build dash tag, that is then your Docker Hub username / your app name, and then the tag you want to give to your app. So in this case, if you want to build an image, want to build our application image, what we'll basically do is we'll come here, let's clear our terminal, and then we'll do something like first of all, let's say docker container ls, as we want to list our containers. Okay, so it's telling me cannot connect to the docker demo at it's like docker is not running. Okay, let me just open let me start up docker. Docker is not running. So once you have the desktop application installed, you can just spin it up, so you will log in and then get started. So it's like it's taking time here, and I don't know what there is I don't know. Okay, it's about to start. As you can see, it's kind of loading. Okay, it's up and running now. So if you come to containers, we don't have any containers. Come to images, we don't have any images. Okay, so I'm already logged in, but if you're not logged in, you will see a button here saying sign in. So once you click it, a tab will open in your browser asking you to log in actually. So you will log in and then it will redirect you back to your desktop application. So now if you go back to our terminal and then run, okay, if you come back to our terminal and run okay, so I don't think this is actually the application where okay, here it is. If you come back to, let's run the command again, docker container ls. Okay, so now we have container id image command create. We don't have any running containers, so now we want to create we want to like build our application image. So what we want to do is we say docker build dash dash tag, the docker hub username, the application name, and then the tag. So basically we'll give this command docker build dash t, and this I will say coding symbol slash kctm. Then I will specify the version. That's I'll make the tag more robust. I'll say kctm, then a colon. I'll say 0.0.1 dot release, and this is just the let me say the fancy way of doing it. It's been really, you're trying to say it's been released, and this is the version 1 of your image actually. So now I'm trying to create this. So if I what I'm trying to say, the app which I'm building this image on is located in the current directory. So as you can see here, I actually specify this dot here is trying to say the app which we're building this image on is located in the current directory. So you just say space and then this if it's located in another directory, let's say in the project directory, you say something like those / project. That is where your application is located. But in this case, it's located in the current directory, so you just hit space and then a dot here, you hit enter. So let's see what is happening. Okay, I think we should expand this a little bit. Okay, the building 3/4 load build definition from Docker file, transferring Docker 15. It will take a little bit of time. We don't have any Docker ignore file here. This actually is building from Docker Slim, as you can see, and the SHA is 256 this from Docker IO library nodes Slim. So I actually use the Slim version so that it will be a kind of faster. Okay, so I think we should wait for it to finish building 5/10 46.1 seconds. Okay, while it's building, let's take a look at our docs once more. So in here, so docker container ls to list our containers, and then to run the container, you mapping port 3000 in the container to port 4000 on your host machine. You run docker run -d -p. -d means detach, so that you free up your terminal and then you run your application. Then -p, you want to forward your port. This port forwarding, you want to forward the port 3000 running in Docker in the container to port 4000 on the host machine, which is your computer system. You want to forward port 3000 from the Docker container to port 4000 on your machine, and then you specify the application name actually, or the image name. Okay, so once it's done, okay, as you can see, transferring context 160.50 MB, okay, directory copy package JSON, run npm install. So it's running the npm install command right now. So we have, I think we have a whole lot of packages here. We'll just give it a little time to complete. we have, and in case you don't know, you can specify if to copy only, I mean on if to run only the, to install only the production dependencies, or build the development and production dependencies. But in this case, we are installing everything, both the production and development dependencies. So it depends how fast our network is, but I believe it's not going to take that much time. And after this, we'll push our image to the Docker Hub. Sorry. And once more, if you're not logged in and you try to push this to Docker Hub, you won't be allowed. So you have to create an account on Docker Hub, and then when you, that same username you're using here, you use it on Docker Hub, and then you log in on your local machine. And then after running everything and making sure your application is running, you can push it to Docker Hub, so it can be public and available to every other person, that the person so that they can pull it and then run it on their local machine. But first of all, let's see what's going on here. Oops, so run this command npm install. Okay, it has taken much of our time already, 223 seconds point. Okay, npm install. This command has already taken 166 point. That's more than 2 minutes. It gets into 3 minutes now. Okay, so it has completed. Now it's running, it's copying everything, exporting to image. Okay, exporting layers. So it's now exporting layers. Okay, so okay, we don't have any running containers. Okay, what we want to do now is let's check our Docker. Go to dashboard, check images. Okay, so now we have an image here, coding symbol slash kctm, and the tag is 0.01 that release. It is unused. It was created 60 seconds ago, and the size is 592.39 MB. And you can actually, there are some actions here. You can push to hub, and you can actually run it, or you can delete it. Let's by not using the desktop application, we can come down here and then run docker run detach mode. Okay, let's run it in detach mode and try to see what we got. Docker run dash dp, we can say dash dp, or okay, let's dash dp, and then we say 3000 port 3000. We want to also use it on port on our local machine. We'll forward it to from Docker port 3000 to the host machine on port 3000 also, 3000, and then we specify the image name, coding symbol slash kctm colon, okay, I think kctm colon 0.0.11 dot release, like this, I think. Okay, let's hit enter. Okay, so we have oops, okay, so we now have a running container. Let's say docker ps, and it's while we're getting nothing. Okay, so now let's check in our Docker desktop application. We have images, we have this container here, started 43 seconds ago. The port in the Docker, the port is 3000, and we are forwarding it to port 3000. Okay, so what we'll try to do here, let's come back to our browser and try to locate port 3000 here. Okay, so there's nothing running on port 3000. Okay. Okay, let's start it. Okay, I guess it wasn't running. Okay. Oops. Exited one. Okay, I think server running on port 3000. Okay, the following locations has been searched: Prisma, blah blah blah, client server, error code undefined. Okay, Debian. Okay, this is related to Prisma and all of that. Okay, but we're forwarding it to port 3000 and I guess it should run. Okay, so let's use 127 like this. Oops. Okay, so why is it not running? But application is actually running here, and okay, let's see what's happening. Okay. We're getting an error. Prisma, blah blah blah. Okay, it's like Prisma is giving us an issue here. As you can see, Prisma client could not locate the query engine for runtime Debian OpenSSL, because as you can see, it's automatically added native Debian OpenSSL 1.1. This is due to the fact that Prisma doesn't run on serverless functions, and this sometimes is added to Prisma has some kind of configurations, but here the app is breaking because of Prisma, and we're not going to fix it. We're just going to leave it like that. You can figure out how to fix that all by yourself. Okay, so now let's come back, and as you can see, we built an image and we're running it. So in order to stop this, we're already running it. So in order to stop it, I think not that. I think we had an ID here, a long ID. So let's copy like the first 4 characters. Let me see. Docker stop. I think we just paste this. Okay. And then if we check our desktop application now, come to containers. Though it wasn't even running, so even if we stopped it, it wasn't running, so no difference. But if it was running, when we run docker stop, it will actually stop. But if we start it here, you can see it's the status here is running, then exited. It started running, then it's due to the error. Okay, so it wasn't actually running. So let's clear up our terminal, check up our docs again. What's the next step we want to take? So the next you want to do is to push this image to our repository on the Docker Hub so that it can be accessible to any other person. So what we do is to say docker push this. I think this is okay. Docker push coding symbol KCTM 0.0.1 dot release. Okay, so hit enter. So the push refers to the repository Docker coding symbol KCTM. So it's preparing and it's also waiting. So let's see what we've got here. It's going to take a little while, and it's pushing. From library node, pushing 12.19 MB of 159.6 MB. Okay, this has been pushed. This also has been pushed. So waiting for first and second. because it's kind of a large in size, 159 MB, 178 MB. So it's gonna take a little bit of time. So let's wait and see what we've got. Oh, okay. Meanwhile, let's come over to let's click here on my username. On the drop down, I'll select my profile, and on selecting my profile, we'll see that we have no repositories. This profile does not have any public repositories. Okay, so after pushing this, we'll refresh and see what we've got. So why is it taking a whole lot of time? Okay, we'll wait and see what we've got. Oops, oops, oops. It's taking time. It's taking time. Okay. Prisma schema. Okay. devdb. It's a binary file, so you cannot view it in the okay, I think it's done pushing. Yes, latest digest size 2843. Okay, pushed, pushed. Okay, everything has been pushed. So let's go head over to here and then refresh. Oops, why is this so? Oops, we still don't have any repositories. Oops, oops, oops. Okay, I think we should just actions, push to hub. Because as you can see, it's like it's referring to the one I tried pushing earlier. The push refers to repository docker io slash coding symbol kctm. Okay, I think it's not done yet. It's not done yet. Yeah. Okay, let's allow this. Because the terminal is not freed up. The terminal is not freed up. Okay. Pushing, pushing. Oh, I actually did not see this. It's still pushing. So I guess we should just give it a little bit of time. I don't know which one will be done first. Hmm? Critical vulnerabilities were found in this layer. Add file this. Okay. Critical vulnerabilities were found in this layer. Okay. That's just that. We're not taking our app to production. We have 16 layers. Add file this. CMD bash. Group add GID env node version 21.1 and all of this. Okay. images. We have 3 images. We have Debian 12 Slim, Coding Simba CTM 0.0.1 release. That's that. Packages 7. Yeah. Okay. Oops, this is taking time. This is taking. I actually wanted this to finish so we can refresh and see. Okay, but that's just it. And after this is done, you can actually head over to Docker Hub and search for coding Simba / KCTM, and you'll be able to find our newly created image. So that's for that. I guess we enjoyed the class, and if you have any questions, you can drop it on the Discord channel so we can discuss it together. Thank you.